All right, Bernardo, here we go. So, question number 5. Check my pen. All right. The nth term of an arithmetic sequence is given by that. State the value of the first term u sub 1. So that's easy peasy. U sub 1, we just plug it in. 15 minus 3, with u sub n being there, of course. 3 times 1. So u sub 1 equals 12. Easy money, also 1 mark. All of these should be fairly quick just because of the number of marks. B, given that the nth term of this sequence is negative 33, find the value of n. So u sub n equals 15 minus 3n. And they're telling us that u sub n here, whenever they say the nth term of a sequence is negative 33, they're saying u sub n equals negative 33, right? So that means we replace u sub n with negative 33. They're finding the value of n, so we're solving for n there, which is telling us which term it is, right? So subtracting 15, we get negative, I hope, 48 equals negative 3n. Divide by 3, and we get n is equal to, or negative 3, n is equal to positive 15. A term number is always going to be a positive integer. It will never be a decimal, and it will never be negative. So just keep that in mind. C, find the common difference D. Okay. I'll go ahead and do it. Like we know u sub 1 equals 12, right? U sub 2 is going to be 15 minus 3 times 2. So that's 15 minus, minus 6, which is 9, right? So D equals any term minus the previous term, which is negative 3. Okay. Now, and a quicker way to do it, if you remember, right, in an arithmetic sequence, once you break it down to the form y equals mx, right, mx plus b, here's the mx, and here's the b, the common difference is the m, the slope, right? You can do it that way. But if you're unsure, just go ahead and get consecutive terms, subtract, and then you're in business. So, okay, moving on to number 6. Let me throw this bad boy up here. How far? Let's see. 3 questions. Okay. In this question, give all answers correct to 2 decimal places. Fine. Sam invests 1,700. Excuse me. In a savings account that pays a nominal annual rate, so once a year, of 2.74, compounded half yearly. Great. So every 6 months, Sam makes no further payments or withdrawals from this account. Great. Find the amount that Sam will have in his account after 10 years. Okay, so I'm going to make this smaller just so I have room to work on here, right? And I think I gave you this formula before. I mean, you can turn it into the formula we use for a geometric sequence, but I think it's just easier to think of it as this, right? So A, the total amount in the account, whether it's a loan or an investment account. Let me double check just to make sure that I give you the same one I gave before. Give me 1 second. Okay, so it's A equals the initial loan or amount of investment in this case, and it's an investment of 1,700 times 1 plus the interest rate R over the number times it's compounded per year, and same thing, number of times compounded per year. T is time in years. Okay, so find the amount that he'll have in his account after 10 years. Great. So we're solving for A. His initial investment is 1,700. 1 plus the interest rate of 2.74. So as a decimal, that's 0.0274. Hold on, I'm looking out the window, Bernardo, and there's turkeys. Cam, there's turkeys! You might have to fast forward for this, Bernardo. There's wild turkeys out front. Yeah, get out of the shower. There's wild turkeys out front. Hurry, they're getting away.
Oh, wow. Oh, my
They were
gosh.
right here.
He said they nest up in those trees.
Oh, really?
Yeah. Wow. Did you get a good picture?
Uh, they're right here, and I was going to get there
4, 5, 6.
quickly.
Wow. That's cool.
Cool. Sorry, Bernardo. Wild turkeys just went right in front of us on our little ranch here in San Marcos, Texas. So hopefully you fast forwarded through that. I'm going to try and get a photo. I took a photo, see if there's a good one. Nah, well, I'll show you that. Done. Okay, all right. I did it. There it comes. I think you can see it. Let's see. Open. Anyway, yeah, there's one there. There were like six of them. They're all in a line over here, Bernardo. I know it's very exciting for you. Um, anyway, I'll show you some more a little bit later. Okay, sorry, all excited. Okay, here we go. Back to this. So plus 0.0274 um, over n, and it's compounded half yearly, so that's over 2 to the n times t, so that's 2, and they said after what, 10 years, so 2 times 10. And I don't know, on my calculator, I'd probably enter it. I'd probably just leave this alone because we can put it in nicely, and I'd probably only change that, but that's totally up to you. All right, let's get those turkeys out of here. So 1700, 1 plus point 0274 over 2 to the 20th power. Hopefully I entered that correctly. I'll throw it on the page just to be sure. All right. And 1700.02742 to the 20. Good. So that's correct. And do they say to the nearest anything? Oh, they said to two decimal places. Round everything to two decimal places. Okay. So then our answer would be 2, 2. Oh, it's already there. Yeah, this would be our answer. Okay. Rounded nicely. All right. So let's do part B. Uh, let's see what's going on with part B. David, that's me, also invests 1700 in the savings account that pays an annual rate of interest of R% compounded yearly. So that's once a year. David makes no further payments or withdrawals from this account. Find the value of R required so that the amount in David's account after 10 years will be equal to the amount in Sam's account. All right. So we're using the same formula. It's just that n is equal to 1, which makes it a little easier. And we're solving for R, right? So that's the only thing that'll be blank. And it has to be the same as who's the first dude? Sam's account. So our equation replacing A with 2231.71 has to be equal to his initial amount, which is 1700, just like Sam's, times 1 plus R is the interest rate. And we don't have to put it over N because N is simply 1, right? An annual rate of interest compounded yearly, so once a year, to the N times T. So N is 1, T is 10, 1 times 10 is 10. So we just have to solve for R. So let's clean it up a little bit. So we're going to take 2231.71. We're going to divide it by 1700. And I think I'm going to leave it like that for now and say 1 plus R to the 10th power. So I can now, let me move up here. Since there's not a variable up in the exponent, I can just take the 10th root of this guy, take the 10th root of both sides. So the 10th root of 2231.71 over 1700 is equal to 1 plus R, and then I just have to subtract 1. So the 10th root whoop, whoop, of 2231.71 over 1700 minus 1 equals R. So here we go with our calculator. Okay, let me make it a little, there we go. I can see it. Okay, so 10th root is this guy right here. So I'm going to do control, boom. Wait, what happened? Escape. I think I have to go to this. Let me bring this down a little bit. So, oh, there it is. Yeah, it already populated. So control gives me that, and then I just pop in 10. And then here I'm gonna do the fraction because I really like it. 2231.71 over 1700. Bonk. Minus 1. Oops, I got to make sure that's out of the square root. I got to arrow out of the square root to do the minus 1. Boom. And there we go. So let me put that on there so we can write the answer down. Okay, we'll bring this over here. Nope, wrong thing. Okay, so now I'm going to follow the letter of the law here where it says give all answers correct to two decimal places. So the interest rate as a percent, we're going to move that over. So that would be 2.7, 1, 2, 5, right? But to the right of the 5 is an 8. So the 5 rounds up to a 6. So 2.76%. Okay. And now 6C. Find the interest David will earn over the 10 years. Okay, so that means we're going to have to um, recalculate the amount or calculate the amount David is going to have after 10 years and compare that to the original investment. And then that will give us the amount of interest he earned. So for David, the amount he'll have after 10 years is 1,700 times 1 plus r to the 10. So that's 1 plus 0.0276, right? To the 10th power. All right, here we go again. So 1,700. Oops, I always have to do this. I forget that. 1,700 times 1 plus 0.0276 raised to the 10th power. Boom. All right, so that's 2231. Let me make sure I got all that right. 0.0276 to the 10th. I do. And so then minus the 1,700 is the amount of interest he will have earned over the life of the loan. So we'll go in here and then we'll write an appropriate answer. Right? So you probably want to write this in 2231.98, right? And then we subtract minus 1,700, his initial investment, and we get $531. And the 7 rounds up to an 8 because to the right, the 8 is greater than 5. So that's going to be 98 cents. So that, sir, would be the answer. Okay, I'm going to stop this, upload it, and make another video.